Hello everyone, Anthony here with the first episode of what's going to be a multiple series where I'm going to program a complete blockchain, a complete modular blockchain from scratch, from a blank page in Golang. I'm going to use Golang version, let me quickly see, I'm going to use Golang version 1.18, which includes the generics, which is nice. The reason for this project is I want to do this for a very long time now. We are in a bear market. Well, we can consider we are in a bear market, and I think it's time to stop crying and to start providing more value, to start building. And a lot of people know on a high level perspective how blockchains work, but I think they don't know, or they have not a complete knowledge of how it works under the hood, and it's very important. Blockchain has a lot of aspects, a lot of components, and yeah, I just want to create this thing with some nice ideas I have from an engineering perspective, and bring some value to the community to let people see how it all works, how you create some blockchain from scratch. So without any further ado, let's just start this thing up. This is not going to be like a tutorial series. It's more of me live coding this blockchain piece by piece, and I will try to explain as much as possible as I go along. But if you have more questions, please feel free to ask them in the comments or poke me on Twitter or whatever. So first of all, I need to give it a name. I have no name in my mind, but let's just call it Project X and change it up later. Yeah, like this. Like this. Let's just start with setting up the project. How I do things is basically touching a makefile, code it up. I'm using Visual Studio Code with the Vim plugin for people that want to know it. Makefile. You want to build this thing. Yeah, like this. Run. Build. This, now we need to test it, of course. Alright, close. Let's make a new file maybe. Just making sure everything is working. Hello world. Yeah, we need to init this. Go mod init. I'm gonna put everything on GitHub. I will provide the link in the comments. So if you want to follow along, or you want to clone it or fork it or help it, it's all good. Project X. And now we should run this. That's working. Test this. It's working. Okay, cool. Nice. We are Gucci. All right. So I had in mind. It's not planned. So I have. It's just me live coding my thoughts on paper. But I have some general ideas. So I think we should have some. Like I said, it's going to be a very dynamic, very generic blockchain, where people can write a lot of adapters, can configure it, can write their own implementations for transport and whatever. So I think to start off, we should have something like a server, which is a container. Then we have a couple modules in it, and I think we could start with the transport layer. Transport layer could be something like TCP, UDP, WebSockets maybe. I'm going to start with a local transport, which is something I always do because it's nice to test things without the hassle of TCP and everything. And then we should move on to actually try to code a block, try to code a transaction, making key pairs, and so on and so on. So let's start this thing up. Let me see, we should have some folders. Yeah, let's do that. Let's create some folders. We need network. All right. Cool. Well, let's create a server. Type server struct. Oh shit. Yeah, I'm a bit rusty on the keyboard. It's a new one, so my muscle memory is still getting used to the old one. So we have a server. How are we gonna do this? Then we're gonna make server ops. So basically the server is a container which will include every module. It's basically just a container object we're going to use. Server options. So we need to have transports. We're going to have multiple transports layers, which will be a transport. We don't have transport, so we will make it. New file. Transport. And this. And it's going to be an interface, I guess. Transport. Interface. What do we need for this? We need an RPC. RPC is going to be the message that's going to be sent over the transport layer. We need a from. It's going to be a string. And we need the payload itself. And we could do two options here. Or we make it an any, or we make it a byte slice. I think a byte slice would make more sense because we're going to send bytes over the network and nothing else. Decoding and encoding should be done on another layer, I guess. Okay, cool. Transport interface. This will all make sense as we go along. I'm just trying to spit my brain into the mic. Transport. We need to connect with another transport. Should return an error. We can do something fancy with channels. Consume, which will return a channel of RPC. Because basically the transport will is a module on the server, and the server needs to, in some way, the server needs to have access to all the messages that are being sent over the transport layers, and it can do that with this consume method. Connect, send message, which will be to. Wait, I have an idea. Instead of making this a string, we're gonna do like type net address. String. And then we do this. And of course we need bytes. That's what's going to happen. And we return an error. Why not? Help. And to make it complete, maybe we could do this, which will return the net address. Yeah, I think we're good. So the next thing we need to do is make an implementation, and I think we could start with a local transport, which is going to be something we can use for testing and to boot up nodes without the hassle of TCP and anything else. So package network. Type local transport. Please transport struct this. Let's open up our server real quick, see what's going on. Transport, it's not gonna work. Yeah, it can work, it's in the same thing. Okay, cool. So local transport. What does it need? We need to have an address, maybe just like this actually, which is a net address. we need to have peers, which is a map of NetAddr, because the transport will have is responsible for maintaining and connecting to peers, so we need a map in order to track them of local transports. We need to lock this thing, because otherwise we will have issues. It's going to be a sync rw mutex, read write mutex, and we need a consume channel, which is a channel of RPC. Okay, cool. So now we're not going to implement all these interfaces. Wait, first of all, let's make a constructor, new local transport, which will return visual case. Local transport return you can give it an address, this we need a consume channel, make chan RPC. Let's make it this. We need peers, make map net address local transport. I think we're good. Okay, so let's start with consume, which is very easy. T local transport consume chan RPC and consume channel. Let's take this, make it ourselves a little bit more easier. Connect transports error help. Cool. Okay, so how are we gonna do this? Connect. Let's say we do basically local transport should connect to a local transport. That doesn't matter. Lock. It's not reading, it's writing like this. Refer reading lock. Could do something like this. I'm just thinking, should we not make it more explicit? Because we connect to a transport, we cannot connect to any transport. We should only connect to local transports, to be honest. I think local transport like this. And then we have this. The reason why we make this an interface is because we can have, the server can have multiple transports. We can have a local transport, a TCP transport, a UDP transport, maybe a WebSocket transport, whatever. People can write their own transports, it doesn't matter, as long as they comply to the transport interface. So what is wrong with this? Oh yeah, it's okay. We don't need to return an error because there is none. This, to be honest, it is what it is. It's cool. So we can connect, which basically for a local transport is very easy. We put it into our peer map and we call it a day. The next thing is send message, which is more interesting. Let's put it here. Copy this. Send message. to net header and then payloads. There's a byte. Like this. We're going to relog this. Take a lock. Wait. Like this. So we're going to send a message. We know to what peer we're going to send it. So we need to fetch it from the peers map, which is going to be 2. And then we say peer OK. And if the peer is not existent, I'm gonna return an error. fmt errorf. Could not send message to %s. And maybe we can make it more explicit and put our own address in here, so we know. Keep an error like this. So we have our peer, and then the only thing we need to do is put this in the consume channel. We can pipe it directly in it, RPC. From is going to be ourselves, so we steep an address, and the payload is going to be the payload like this. And then we can just return nothing, help, and we should be Gucci. All right. Do we need something else? I don't think so. Okay, so let's try this to make a test, which is always a good thing to do. Local transport test. Go like this. Package help network test connect. Testing.t. Normally, we're going to try to use SLS, third-party packages as possible, but for testing, I'm always using the Testify package. So something we need to install. Go getup.com. I think it was Stretcher. Testify. Let's test if this is working. Assert equal t1 1. It's not importing it automatically for some reason. Assert maybe. Yeah, cool. All right, so how we're going to test this is basically, let's open up transport here, local transport I mean. Yeah, so let's start making a TRA, which is the first transport, is a new local transport, we call it A. Let's make it TRB, B. And then we're going to say TRA.connect with TRB. And this will all make sense later on, you will see. Hold on. So we will connect. Normally we should test the error, but I'm 100% sure there is one. And then we're going to say TRB connect with TRA, and we say that TRA.peers TRB.address should be TRB. Yeah. I'm still not importing it. This is so annoying. What the hell? Stretcher, testify, assert. Okay. And then we're gonna say TRB peers TRA pin address is going to be TRA. And it should all work, I guess. Make test. Yeah, okay, cool. So that's working. Fine. Now we're gonna test the send message, and it should be more clear how this all works. Test send message. Like this. We're gonna do the same thing. Connect those guys up, and then we're gonna say TRA to send message to TRB.address. The message is gonna be a byte. Hello world. Like this, and then we're gonna say assert no, and alright, minus T here, okay, and then we need to consume the channel. So RPC is, so we are sending from TRA to TRB. So TRB and consume, and let's just use the function so we can test it more real world. Because this is a local test file, we could access the private, so basically the non-public variables, but it's better to test this, to test it like it should be used in the real world, and server will have no access, or the outside world will have no access to consume channel, to this thing here. They won't have access, so we need to do this, and then we're gonna just assert equal the message payload. Wait, what is this? No, wait, the RPC pin payload, and it should be the same as the message. Okay, so let's recap. We have a message, hello world. We send that message to TRB. We consume the channel, the consume channel from TRB, which is an RPC, and we assert that the message we sent is the same as we consumed. And then what you also can do is equal T RPC pin from, which is the sender. Actually, I don't know, maybe we should call it sender, but from is also good. So the from is the TRA pin address. And let's test this. Make test. Cool, so that's all working. So we're Gucci. So let's go back to server, and let's try to implement the first transport of our server, blockchain server object. So wait, I'm thinking, let's open main. Okay, let's do first new server. Help. The options, which are the server options, and we will return, for now a server is fine. Later on we should return an error, but for now we don't have any. So we return a server like this. Help. So we need to embed the server options here. This server options or ops, and then then we can say, let's do okay. So let's try it. So let's do ops is network. Server ops. So that's the problem. Sometimes it just doesn't auto import my own packages, and it's annoying. Project X, I guess. And then we say network server ops. transports. Let's do this just for the sake. Is it gonna import it? Of course not. Local tr local new local transport. Let's name it local. What the hell is going on? Oh man. NTM project X. Why is it not working? What did I do wrong? Alright, cool, it's working, finally. So this is our local transports, and able to understand this a little bit more better. So we have our own machine, which is the running machine, which is our local node. So we have a transport for our own node, server, or whatever you want to call it. And then we will have peers, which are remote peers, which will represent servers in the network, which are not our machine, if that makes sense. So we have our local nodes, str local, like this. Then we say server is a network, new server with options, which will, for now it's just transport, but it will be a much bigger object. What is this? What is this error? What's going on? Yeah, indeed, it's multiple transports, so we need to do slice transports, and then this. It's going to be a network per transports. Yeah. What the hell is this? Come on. Yeah, okay, I see what the issue is. Let's go back to transport, local transport, I mean. So basically, this should return a transport. And now, yeah, exactly. So let's make it super generic. So this needs to be a transport like this, and then we need to cast this to a local transport. Fine. All right, cool. So we have a server. Fine, cool. The next thing is, let's make the server do something interesting with the server. Let's do func. Server init transports for tr transports. So what are we gonna do? So when the server, it will be very clear, trust me. So let's say func server start. We're gonna say aspect init transports. So for every transport we have, we need to make them listen for messages. So we're gonna start a go routine for each transport. So it's gonna be like this, and then probably this is server, right? So it's good, so we can do this. Okay, come on, Visual Studio Code, please, man. Transports. This is fucking... Okay, cool. TR. And we're gonna say for RPC in range tr.consume. So we're going to consume. So for each transport we have in the server, we will spin up a new go routine. And then we will basically keep reading forever the channels. We will keep consuming their message channels. And that we need to make sure, wait. Let me see. What is this? What did I do? No worries. So first of all, I need to do something else. I think I need an RPC channel in this one. Channel RPC. It will be very clear, trust me guys. Just follow along. It will be super duper clear. It's going to be a channel RPC. I need to make it because I'm a bit confused for myself now. Channel RPC. This. You're in network, so it's okay. Go funk. Yeah, okay, perfectly fine. So instead of handling, so we could handle for each message coming from the transport, we could handle it right here. But we have a big problem because it's basically Go routines all over the place, and there is nothing that tells us that the messages being handled in this Go routine is gonna be thread safe. Or we could use a lock and do some nasty stuff. I'm not a big fan of locks, but sometimes you need to use them. Or we could do something neat, and it's basically pipe every RPC that's coming from the Go routines from each transport directly into the server its own RPC channel, which will make sure that this will be a synchronous operation. And you will see what I mean by that. So when we start the server, we're gonna make a loop, and we're gonna say something like case RPC is our own RPC channel, and here we're gonna handle the message, but we are not gonna handle it ourselves because we're gonna make it generic. So we need to have some kind of a protocol handler that will basically handles the protocol for us, handles the RPC for us. So we can create our own implementation, other people can create their own implementation, super generic. So RPC, let's say for now we're gonna print this out, print ln or print f maybe. Let's do this, v I guess, yeah, RPC. Alright, so now s print RPC chan. And then we pipe this into this, and we are Gucci. Okay, so this 4 is complaining. I think it's because we're using one case statement. Okay, cool, but that's no worries. We're gonna make a quit channel, chan struct. Yes. Quit chan, make chan struct 1. And we're gonna say case s quit channel. We break. What the hell is this? Oh yeah. We're gonna do free. Break free. Okay. So this is all placeholder. It's just scaffolding this stuff. We're going to make everything much more better and whatever in the future. It's just getting things up and running. First make it work, then we will make it better, and then we will make it fast. So server shut down. Yes, and then we have this. The problem is, so what's going to happen with this Go loop, and you will see, I will show you. So on main, we call our server, we instantiate it with a transport, configured with a transport rather, and then we say server can start, and then we can say make run, and we fuck it up. You see, all Go routines are asleep, and that's perfectly fine. So we can solve this by doing a default statement here. And for the people that don't know what this is, it's basically, let me get my mouse. So it's basically a for select. So it will keep looping and it will check, is there something to consume from the RPC channel? Is there one? Then we will print it out. Then it will check, basically, if there is no RPC channel, they will check, do I need to quit this? Yes, I need to quit this. Then we break free. So we break this loop, we come here and the program just stops. And if there is nothing else, then we are fucked, because then it basically freezes up. And if we do a default statement, which basically is the same as a switch default, where if nothing else hits, then it will go here and we do nothing and it will just keep looping. But that's actually, to be honest, this is CPU very intensive. So what we could do is a very nice trick I can show you. And it's basically not a trick, it's something we need. And because this is basically our server, and for now it's very small, we only have a couple things in it, but it will also hold our transaction mempool. So each time somebody sends a transaction, it will go into the mempool, and this mempool will need to be checked, it will need to be pruned, there's a lot of things that will need to happen with this mempool. It's the same thing for blocks. We will have some kind of a blockchain handler, dynamic generics, I'll keep saying dynamic for some reason, a generic thing, a generic interface that will handle everything about blocks. And maybe we need to persist the blocks each every 5 seconds or each every 30 seconds, whatever, I don't know, I'm just saying. So this can help. So enable to do this, we could do did, for example, ticker is time print new ticker. And we, for example, let's say it's 5 seconds, just for the sake of this, time in seconds. And then instead of this default thing, wow, this Visual Studio Code and this Vim plugin is killing me. So case time wait, ticker .c. So each time the channel of this ticker is so each 5 seconds we can say md help println. We can say do stuff, do stuff every 5x sec, like this. So if everything is good, let me double check, and we start our server right now. Okay, cool. So as you can see, we have our server up and running, and it's doing stuff every X seconds in the console. So that's good. The problem is we want to send messages. We want to make something cool, right? And that's that's going to be the first, for the first episode. We're going to make this work. So what do we need to do? We have our local transport. Okay, cool. Let's make a remote one. So tr remote is going to be network new local transport. Remote. I know this is confusing. I really understand. So, so we're saying that we are making a new local transport, but it's a remote. But you need to think about of the local transport is, instead of, it's a way of communicating type. It's not a TCP. It's not going over a TCP. It's not going over a UDP. It's going over local. I cannot explain this, but it should make sense for you. It's going over code, if you know what I mean. So we have our local transport, which is our own node. We have the remote, which is somebody else in the network. And we're going to connect those guys together. Normally it will go over messages and RPC in the server, and that's for the future, but just for the sake of demonstration, we're going to connect them. So tr local. So a connect method for TCP would be something completely different than that we did for a local transport. Just a heads up. So we are going to collect a local node with a remote, and well, we can also connect the remote with a local. Why not? We can do anything we want. It's our world. It's our chain. We are the boss. Okay, so they are connected, and then then we're gonna make a go routine like this, and we are gonna say that the remote is gonna send messages to the local node. We're gonna say byte hello world. Why not? Always nice to start with hello world. And we're gonna do this basically, we're gonna keep doing this just for demonstration. We're gonna keep doing this, and we're gonna sleep here every time, one times time per second, every second. Yeah, okay, cool. Let's recap. So we have our local node, we have a remote node, we connect those two, and we're gonna say that the remote node is gonna keep sending messages to our own node every 1 second in a separate go routine. Then we're gonna make our server. We're gonna configure our own server, which is nothing more, server, node, whatever you wanna call it, daemon, something that's holding all of our things. We're gonna configure it with our local transport, and we're gonna start it. If we start this, it's gonna spin up its own loop, which is listening for each single transport and piping the messages that those guys are interacting with each other into its own channel, so we can then here handle that message whenever we want. So let's just start this thing up and see what goes. Make run. Yeah, okay, cool. We need to just make it's working, but we need to put a new line on this. Wait, where are we? Here. Here. New line like this, and then make run. Let's clear first. Make run. Okay. So that's basically what we have. So we have a transport layer. We made a local transport. We created a basic scaffold of our server. We can configure it with a transport, which is local for now, and we can send messages. That's basically the first step from our fantastic modular blockchain. So I think I can wrap it up for now. So now we have our local transport. I think for the next episode, we're gonna start doing some more. We're gonna hop from different components here and there, just to make it more, the episodes more dynamic, more interesting. So now we have our local transport. We will start with blocks and transactions, and we are gonna make our own key pairs. So we're gonna make our own addresses. We're gonna sign transactions, and so we can basically send those guys over the network to each other and put them into blocks, and it's gonna be amazing. It's gonna be nice. So this is for the first episode. If you guys like this first video, please like the video on YouTube, subscribe to the channel, leave something in the comments, give some feedback. Maybe I made a mistake, I don't know. I'm not perfect. It would be nice to interact with you guys. Thanks for watching, and see you in the next episode. Peace.